Polynomials pre-assessment. Show all work on each example. Let's look at the first one. 2a. I could describe characteristics of polynomial functions. Identify the characteristics of the function graphed in red. The gray dashed function is the parent function to the reference for the transformations. The type of function this is called a cubic. Here are some common polynomial function names. We have constant functions for functions that are just like y equals some number, linear, quadratic, cubic, quartic, and quintic. The domain for all polynomials, unless they're bounded by something, is all real numbers, negative infinity to positive infinity. The increasing interval, this has a positive slope everywhere, so it's increasing everywhere. And then it's not decreasing at all, so we're going to put nowhere. The range for odd degree polynomials is all real numbers. The end behavior on the left side is going down, and on the right side is going up. So we'll put left, down, and right, up. There is no reflection. If there was, it would be facing this way. Dilation, it looks like it gets skinnier right here from the dashed one. So we're going to put a vertical stretch. Horizontal translation, so from the origin to the new center, it goes to the left. And then it also goes down. Let's look at the next example. I could describe characteristics of polynomial functions. Note, the parent function is f of x equals x cubed. Identify the following characteristics for the function g of x equals 6 times x minus 1 cubed. There is no reflection since this 6 is positive. The 6 is bigger than 1, so the dilation is a vertical stretch by 6. Your horizontal translation right here, if you were to graph this on Desmos, you would notice that it goes to the right, 1 from the origin. And it doesn't go up or down, so we're putting none. Instead of there being a plus k visible here, there's not, so you could just put plus 0. Let's look at the next page. I could describe characteristics of polynomial functions. Identify the characteristics of the function graphed in red. The gray dashed function is the parent function to the reference for the transformations. The type of function this is most likely is quadratic. The domain is all real numbers, negative infinity to positive infinity. Your increasing interval. We're going to draw a line going through the vertex, cutting it in half. One side's increasing, one side is decreasing. We start right here. On the left side, we have a positive slope that's increasing. On the right side, we have a negative slope that's going to be decreasing. The value right here that divides the two halves is going to be 1. So it's increasing on the left side. X is less than 1. So from negative infinity to 1, the left side. And then it's going to be decreasing on the opposite side. So x is greater than 1 from 1 to infinity, the right side. The vertex is right here. Looks like we have 1, 3. The range is opening downward, so y is going to be less than or equal to 3. In behavior, on the left side is going down, on the right side is going down. Down, down. So we have left, down, and right, down. We have a reflection. When it's upside down like this, it has a max, it reflects. Dilation, it looks more horizontal than the original, so we're going to put a horizontal stretch. Also known as a vertical compression. From the origin to the new vertex, it goes to the right and it goes up. And let's look at the next one. 2a. I could describe characteristics of polynomial functions. Note, the parent function is f of x equals x squared. Identify the following characteristics of the function g of x equals 4x squared minus 1. If we were to sketch this graph, it would look something like this. The increasing interval would be on the right side in this case. The decreasing interval would be on the left side. So increasing would be x is greater than 0. So from 0 to infinity, the right side. And the decreasing interval would be x is less than 0, negative infinity to 0, left side. Axis of symmetry is that line that goes through the vertex. X equals 0. The extrema is a minimum at y equals negative 1. The vertex is those two numbers put together. 0, negative 1. The range is opening upward, so y is going to be greater than or equal to negative 1. Horizontal translation from the origin to this one, it doesn't go left or right, but it does go down. It goes down 1. And this 4 right here makes it have a vertical stretch by 4. Two A, I could describe characteristics of polynomial functions. Identify the following characteristics of the polynomial function. F of x equals negative 5x cubed plus 7x plus 11. If we refer back to the page from before, notice the one with the x cubed is called cubic. So our type of function is cubic. Our degree is 3. It's the largest exponent. The leading coefficient is negative 5. And the end behavior, we'll look at this chart right here. So we'll go ahead and draw out this chart. So when we have an even degree and a positive coefficient, you're going to have up, up. It doesn't actually matter what happens in the middle. It's just the end behaviors is going to be going up at the beginning and up at the end. For a negative coefficient and even degree, it's going to be going down and down. For odd degree positive coefficient, it's going to be going down, up. And then for an odd degree with a negative coefficient, it's going to be going up and then down. And again, it doesn't really matter what happens too much in between. These are the 4 cases of end behavior for polynomials. So by looking at this, we know we have a negative leading coefficient and we have an odd degree. So we're going to look at our chart, negative coefficient, odd degree. We have up, down. We have left, up, and right, down. And the graph will look something like this. The leading term is negative 5x cubed. Is a function even, odd, or neither? For this, you look at all the exponents. If they're all even, then it's even. If they're all odd, it's odd. If they're both, you put neither. Our exponents here are 3, 1, and 0. It's 0 because 11 is really 11x is 0th power. We have an x, the exponent is 1. Now, 3 and 1 are odd numbers, but 0 is an even number. Since we have even and odd exponents, our function is neither. And our constant coefficient is 11. Let's go to the next one. I could describe characteristics of polynomial functions. Identify the following characteristics of the polynomial function. F of x equals 7x squared plus x to the 4th power minus 6. The type, well, before we even look at that, notice that the term with the highest exponent is not in the front. Since this is the case, we have to reorder it. So we're going to say rewrite in standard form. So that's going to be f of x equals 1x to the 4th power plus 7x squared minus 6. And remember, that really has x to 0 power there. So we're done with this. We don't have to look at that right now. We're only looking at our standard form equation. So our type is quartic. The degree is 4. Leading coefficient is 1. The end behavior, we're going to refer to our chart from above, is a positive even. So let's look at that. So positive, even, up, up. So it's going to be left, up, and right, up. So it looks something like this. Our leading term is x to the 4th power. Is the function even, odd, or neither? Our exponents are 4, 2, and 0. They're all even, so this is even. And our constant coefficient is negative 6. The next section is about factoring. A.10d. I can factor out the greatest common factor. What is the GCF of 2n squared plus 50n? So if you're not sure, you could put them right here and just try to divide out numbers. Well, we could divide out 2 here. So 10n squared plus 25n. We could divide out 5. 2n squared plus 5n. We could also take out an n because both of them have an n. So that's 2n plus 5. There's nothing else to take out. Our GCF is the numbers that we divide out, multiply together. So that's 10n. That is the GCF. And then this would be what's left inside. So your factored form would be 10n on the outside and then 2n plus 5 on the inside. A.10f. I can factor the difference of squares. Here's the formula for difference of squares. A squared minus b squared equals parentheses a minus b times a plus b. The sum of squares formula, a squared plus b squared, would be parentheses a minus bi times a plus bi. The factored form of 9x squared minus 64. The square root of 9x squared is 3x. The square root of 64 is 8. And then we just plug them into the formulas. So for difference of squares, we'd have 3x minus 8 times 3x plus 8. And then for the sum of squares, we'd have 3x minus 8i times 3x plus 8i. Seven E. I can factor polynomials. State the factors. So now we have the sum and the difference of cubes. So if a cubed minus b cubed, this could equal a minus b parentheses a squared plus a times b plus b squared. And there are sum of cubes formula, a cubed plus b cubed equals a plus b parentheses a squared minus a times b plus b squared. Now notice the only things that change here, the formula, is the first operation sign and the second operation sign for addition and subtraction. Now notice that these are the same. And then these two are opposite. Same thing for the other formula. So if a cubed is x cubed, then a would equal x. 64. So if b cubed was 64, if you get the cube root of 64, that gives you 4. So b equals 4. A common mistake here is to say that this is 8, but we're dealing with cubes instead of squares. So now let's plug in the a and the b into our formulas. We have x minus 4 parentheses x squared plus 4x plus 4 times 4, which is 16. And then we write the same thing, except for we change those two signs. Notice the last addition sign stays the same for both formulas. That is because a negative times a negative is a positive, and a positive times a positive is also a positive. Let's look at the next one on here. 10e. I can factor quadratics. If the factored form of 3x squared plus 39x plus 108 can be factored into a times x plus r times x plus t, what are the values of a, r, and t? So first we want to see if we could take out a greatest common factor. The GCF ends up being 3. So we're going to divide all three of these by 3 and rewrite it. We have 3 parentheses x squared plus 13x plus 36. We get these because 3 divided by 3 is 1, 39 divided by 3 is 13, and 108 divided by 3 is 36. We didn't divide by variables, so we would leave the variables alone here. From there, we're going to identify our a, b, and c to help us factor. We have 1x squared, we have 13 x's, and we have 36 constants. So our x, we're going to have a times c here and b down here. 1 times 36 is 36, and then our middle term is 13. We will find two numbers that multiply to give you 36, and they add to give you 13. If you're not sure right away, you could also list factor pairs. We know that 6 times 6 is 36, so we don't need to go on to 7. So our factors need to give us 36, and we need to get a sum of 13. 36 divided by 1, that's 36. 36 plus 1 is 37. That's not 13. Let's go to the next one. 36 divided by 2 is 18. 18 plus 2 is 20. That's not 13. Go to the next one. 36 divided by 3 is 12. 12 plus 3 is 15. That's not 13. Go to the next one. 36 divided by 4 is 9. 9 plus 4 is 13. That's what we want. If we divided it by 5, we would get a decimal, and 6 plus 6 is 12. So the only one that will work is 9 and 4. So our factors would be 3 parentheses x plus 9 times x plus 4. We just move these numbers into the factors. So in this case, A would be your GCF of the whole thing. That's 3. R is 9, and T is 4. These could be in either order. When I gave you the answer choices on this one, it only gave you one or the other for each of the options. Let's look at the next page. A.10e, I can factor quadratics. If the factored form of 4v squared minus 3v minus 10 can be factored into av minus b times cv plus d, what are the values of a, b, c, and d? So for this one, it doesn't look like we could take anything out, so our GCF is going to be 1. Let's go ahead and identify our a, b, and c. We have 4v squareds, we have negative 3v's, and we have negative 10 constants. A times c goes up here, that is negative 40. Our b is negative 3. We will find two numbers that multiply to give you negative 40, and they subtract to give you negative 3. Let's write those out right here. So we have negative 40, and then they need to have a difference of negative 3. So 40 divided by 1, we get negative 40. That's negative 39. That doesn't work. Okay, we have negative 20. And let's see, 3 is a decimal, so that doesn't work. We have 10. That's going to be negative 6. So that doesn't work. And then negative 8 plus 5, that's negative 3. So this is be what we're looking for. We have negative 8, and we have 5. Now, a is not 1 here, so we have to keep going. Let's factor by grouping. So I have 4v squared minus 8v plus 5v minus 10. So if you combine those back together, they should give you negative 3v. You have them separated here, so you can factor by grouping. So you're going to make these into groups of 2 terms each. And then we can factor out the greatest common factor of each pair. These two you could take out a 4v. So everything cancels here except for one of the v's is left over. And then we have a minus 2. Okay, out of these two you could take out a 5. And then so we have v minus 2 left. Now notice that we have v minus 2 for both of these. We could take that out of the whole thing. So if we did divide by v minus 2, divide by v minus 2, those all cancel, and you're left with 4v plus 5. So right here, a would be 1, b would be 2, c would be 4, and d would be 5. (7e) I can factor polynomials. Factor completely. 16n cubed plus 12n squared minus 4n minus 3. So for this one, we want to make our groups. We will put a plus sign in between these so that we're not multiplying them. And now we're going to take out the greatest common factors. Okay, out of these two, it looks like we could take out 4n to the second power. And so we're left with 4n plus 3. Out of the second two, we could take out a negative 1. And then we're left with 4n plus 3. Notice they both have 4n plus 3. That means that you can factor it further. So we have 4n plus 3. And when we take it out of this, we're just left with 4n squared minus 1. Now, 4n minus 1 is a perfect square for each of those, so we're going to use difference of squares. So we can factor it further. We have 4n plus 3 times 2n plus 1 times 2n minus 1. Again, we get that difference of squares formula from this previous example up here. (7e) I can factor polynomials. Which of the following are factors of x to the 4th power minus 3x squared minus 28? Select all that apply. In this case, a is 1, b is negative 3, and c is negative 28. A times c is negative 28. B is negative 3. We will find two numbers that multiply to negative 28 and they subtract to negative 3. Let's write our factor pairs of 28. So 28 divided by 1, we have 28. That doesn't give it to us. 28 divided by 2, we have 14. That's not it. 28 divided by 4, that's going to be 7. And that's what we want. So we have negative 7 and positive 4. A is 1, so we can go ahead and stop there. So minus 7 plus 4. Now, these x's are going to need to be squared in this case. They're squared because we start with a 4. We could do this because it's 4 and 2. If it was like 4 and 1, you couldn't do that. Also, likewise, if you had 6 and 3, you could do that. If you had 8 and 4, you could do that, and so on. From there, it doesn't look like you can factor these further unless you want to have irrational numbers and imaginary numbers. So that's it. X squared plus 4 and x squared minus 7. Those are your factors. Okay, let's look at this one. I can factor polynomials. Factor by graphing. X cubed minus x squared minus 5x minus 3. Let's graph this on Desmos. So if we look at our graph, notice we have two different real roots. We have negative 1 and 3. And then we have a y-intercept of negative 3. Let's go ahead and sketch this on our paper. So we're on our paper. Let's go ahead and sketch this graph. So it looks something like that. Now, when it touches right here, it has a multiplicity of some even number. They usually just want you to say the smallest possible number you could have. So we'll say this has a multiplicity of 2. This one only goes through, so it's just a regular multiplicity of 1. So our zeros are negative 1 and 3. So our factors would be the opposite of that. So it would be x plus 1, x minus 3. Now we have a multiplicity of 2 here, so we're going to put that 2 in the exponent. This was a multiplicity of 1, so we have a 1 there, but again, you don't have to write that. And these would be your factors. We have a repeated real root and we have another real root. You have 3 roots altogether because your degree is 3. They could be real, they could be imaginary, or they could be repeated. Let's look at this one. A.11a. I can simplify square roots. If the square root of negative 12 equals a times the square root of b, what are the values of a and b? So to find this, we want to factor out perfect squares. The common perfect squares that you'll most likely see on the majority of these kinds of problems are as follows. The square root of negative 1 is I. The square root of 4 is 2. Square root of 9, 3. Square root of 25, 5. And square root of 49 is 7. It will be one or more of these, most likely, in each of these questions. Square root of negative 12. We have a negative, so we can factor out that I. we have the square root of negative 1 times the square root of 12. The square root of negative 1 is really an I. The square root of 12. Well, 12 is equal to 4 times 3. So we could factor out a 4. That's one of our perfect squares. So the square root of 12 is the same thing as the square root of 4 times the square root of 3. The square root of 4 is really 2, and so we have our answer. 2i square root 3, where a is 2i and b is 3. Let's look at the next one. 7c and a 10c. I could divide polynomials. Find the remainder of 298 divided by 5. Your answer should be a whole number. So our steps is divide, multiply, subtract, break down, and then repeat until the end. We're not adding decimals here, so the end would just be we've brought down the 8. 5 goes to the 2, 0 times. 5 goes to 29, 5 times. 5 times 5 is 25. So we divided, got 5. Multiply, 5 times 5, that's 25. Subtract, you change the sign, it's going to be a minus. You have 4, break down the 8, and then repeat that process. 5 goes to the 48, 9 times. 9 times 5 is 45. Subtract them. There's nothing else to break down, so 3 is your remainder. Your remainder is 3. Your quotient is 59. If you were to write this as a mixed number, it would be 59 and 3/5. 7c and a 10c. I could divide polynomials. Simplify. 16x cubed over 40x. Let's see, we could divide each of these by 8. Okay, 16 divided by 8, we have 2. 40x divided by 8, that is 5x. We could also divide by one more thing. We could divide by x. And then we have 2x to the second power over 5. We took away 1x here. We took away 1x here. We have 0 x's up there. So that's why there's no x's left down there. And that's our answer. Let's look at the next page. 7c and a.10c. I could divide polynomials. Use synthetic division to find the remainder of x cubed plus 27 all over x minus 3. Your answer should be an integer. By the way, integers are in the set of numbers such as -2, -1, 0, 1, 2, and so on. The abbreviation for integer is a z. Why? Because I is already taken with the imaginary numbers. Okay, so this number right here, we're going to set this equal to 0. And so x would equal 3. Our numbers up here will be the coefficients of the numerator. We have 1x cubed, 0x squared, 0 x's, and 27 constants. Break down the 1. 1 times 3 is 3. Add these, you get 3. 3 times 3 is 9. And then 3 times 9 is 27. And then we get 54. So our quotient would be x squared plus 3x plus 9, and then our remainder is 54. If we wrote that as a mixed number, it would be 54 over x minus 3. So your remainder is 54. This is your quotient and remainder, mixed number. (7c) and (a)(10c). I could divide polynomials. Use log division to find the remainder of 42x to the 4th power plus 17x cubed minus 22x plus 38x minus 21 all over 7x minus 3. Your answer should be an integer. So let's write these on our long division. Inside the house, we will write our dividend. It's the numerator at the top of our fraction. And now on the outside, we will write our divisor, our denominator, the bottom of the fraction. Okay, just like with the elementary division problem, we will follow the same steps. Divide, multiply, subtract, bring down, and then repeat until the end. So when we're dividing, we're going to divide the two leading terms. 42x to the 4th divided by 7x. That's going to give you 6x cubed. Let's write that on top of the x cubed term. Okay, we're going to multiply 6x cubed times our divisor. So we have 42x to the 4th and then minus 18x cubed. When we subtract, we're going to change the signs of everything, not just the first term. So this becomes a plus sign. So those cancel out, and then you have 35x squared. Break down the minus 22x squared, and then we're going to move on to the next step. We're going to repeat that process. Divide, but this time the lead term is 35x cubed. So let's divide those off to the side. We get 5x squared. Line that up. Multiply 5x squared by each of these two terms. And then we're going to change the signs of each when we subtract. So it's because of plus. Those cancel. You're left with negative 7x squared. Break down the 38x. Okay, now divide those two. Negative 7x squared divided by 7x. We get negative x. We'll put that at the top. Multiply each of those by negative x. And then when we subtract, we're going to change the signs of all of them. So this is going to become a plus. This becomes a minus. Those cancel. And this will become 35x. Break down the minus 21. And then we'll do it one more time. So we're going to divide the 35x to the 7x. That's equal to 5. So we'll line that up. Put plus 5 here. Multiply 5 times each of those two terms. And then we're going to switch the operations for each. Those cancel. And then negative 21 plus 15 would give you negative 6. So your remainder is negative 6. So your entire quotient would be this, and then your remainder would have that -6. You would type in -6 into that problem. Let's go ahead and erase this stuff so we'll have room in the box. (7c) and (a.10c). I could divide polynomials. Use box division to find the remainder of p cubed minus 20p plus 24 all over p squared plus 5. So what you want to do is write the divisor on the side, p squared plus 5. And there was 0p there, so we're just going to put that there. Sometimes it'll make a difference and other times it will not. Get into the habit of putting it in there. And then in the first box, we're going to put the leading term of the numerator. So we want to find something that multiplies to give you p cubed from p squared. We'll put p. P times p squared is p cubed. Now we're going to multiply p times 0, that's 0 here. P times 5 is 5p. Alright, so on the side here, this one's going to be p squared. This one's going to be p. This one's your constant. And then these are just remainders. So for this one, there is going to be 0p squared. For this one, there is negative 20p's. And then for your constant, you want 24. So let's go ahead and find that. We know that this plus this has to be 0. So this also needs to be 0. Alright, so this must be 0. This is 0, and this is 0. So in this case, we didn't actually need to put the 0p there, it looks like. So we know that if we add all three of these together, it has to give you negative 20p. We have 5p, so we're going to have to do negative 25p to make it into a negative 20p. And then for these two, we have to get 24, so we put 24 right here. Alright, right here, we can't multiply something here to get negative 25p, so it looks like this is going to be your remainder. So this is your remainder right here. The remainder is going to be negative 25p plus 24. And if you were to find the quotient, it's p. If you wrote it as a mixed number, it would be p plus negative 25p plus 24 all over p squared plus 5. (7c) and (a10c). I could divide polynomials. Is n plus 8 a factor of n cubed plus 16n squared plus 56n minus 72? Well, let's try it out with synthetic division. So we set this equal to 0. N would equal negative 8. That goes right here. Write the coefficients. Break down the 1. 8. Negative 8 times 1 is negative 8. Negative 8 times positive 8 is negative 64. Negative 8. We have 64, and that's going to give you negative 8. So this is not 0. So we're going to put no. If you don't get a 0 right here, that means that this is not going to be a factor. 7c and a10c, I can divide polynomials. What is the oblique asymptote of 3x cubed minus 5x squared plus 7 all over 3x minus 5? To find the oblique asymptote, you need to divide it. If you get a remainder that's not 0, the oblique asymptote would be the quotient. Let's do box to divide this out. So on the side, let's go ahead and write our divisor, 3x minus 5. Inside the first box, let's put 3x cubed. The numbers on the side, we have negative 5x squared, 0x, and then positive 7. So we're going to multiply by x squared to get our 3x cubed. Okay, multiply these, you get negative 5x squared. Well, we already had that there, so we don't have to add anything to that. It's going to be 0, 0. This needs to be 0, 0. And then these need to be 7. And so this is your remainder. So your remainder is not 0. So the oblique asymptote would be your quotient. Y equals x squared. Okay, let's move on to the last page. I can solve polynomial equations. Solve for the other zeros. X to the 4th power minus x to the 3rd power minus 5x squared plus 3x plus 6 equals 0. Our given zeros are negative 1 and 2. Using those given zeros, find the other zeros. So to divide those out, we're going to use synthetic division. So inside the box, we put our given 0 and then write the coefficients of our equation. Okay, break down the 1. 1 times negative 1, get 2, 3, negative 6. And then this should be 0 if this is actually a 0. Okay, let's do it again, except for this time we're going to put in a 2. Break this down. Get 2. And then here we go. So this is our x squared term, and here's our constant term. So we have 1x squared minus 3 equals 0. From there, we're going to add 3 to each side. X squared equals 3. Take the square root. It's going to be a plus or a minus. So x equals plus or minus the square root of 3. So our answers are negative 1, 2, plus or minus the square root of 3. Let's do the next one. I can solve polynomial equations. Solve for the other zeros. X to the 4th power minus 4x cubed plus 6x squared minus 8x plus 8 equals 0. The given zeros is 2 with a multiplicity of 2. That means we're going to do synthetic division twice with 2. So we're going to write 2 in the box and write our coefficients. Make sure it didn't skip anything. It doesn't look like it did. If it did, we would need to put a 0 there. And then we'll do it again with the 2. And here's our equation. X squared plus 2 equals 0. Subtract 2, x squared equals negative 2. Take the square root, is plus or minus. And since there's a negative in there, we're also going to put an I there. So your answers are 2 with a multiplicity of 2, and then plus or minus I square root 2. Okay, let's go over the last one here. I can solve polynomial equations. A rectangular pool 18 meters by 12 meters is surrounded by a walkway of width x meters. At what value of x will the area of the walkway equal the area of the pool? So let's go ahead and sketch this out with the box here. So this is the pool. It's 18 meters by 12 meters. If we found the area of that, we've just multiplied those two together, you get 216. This length right here is x. This length right here is also x. This length is 12. So to find this side length right here, we would have x plus 12. 2x plus 12. And in this one, we have x, and then we have 18. So to get this one, it's going to be x plus 18 plus x, 2x plus 18. So let's find the total area first. To find the total area, we're going to have 2x plus 18 times 2x plus 12. Let's do a box to find the area of this. Okay, we're going to find the area of the 4 boxes. 4x squared, 24x, 36x, and then 216. Add these two together, you get 60x. So our total area is going to be 4x squared plus 60x plus 216. Okay, from there we want to find the area of the pool. And that's just length times width, and that is 18 times 12, that is 216. To find the area of the walkway, it is this minus this. So it'd be 4x squared plus 60x. So we want these two to be equal. So let's write that out. 4x squared plus 60x equals 216. Let's move everything to one side of the equation. So we have 4x squared plus 60x minus 216 equals 0. Now, it looks like you can divide out 4 out of all of these terms. Okay, so then we have x squared plus 15x minus 54 equals 0. From here, we can factor this. 115 and negative 54. Let's write the factor pairs of 54. See, 54 divided by 2, 54 divided by 3. Looks like that's what we want. So I have 18 and -3. So we have our factored form, x plus 18 and then x minus 3 equals 0. You have x equals -18 or x equals 3. This will be real. This was extraneous because you can't have a negative distance. Now you can also do this by using quadratic formula. So using that and the same a, b, and c, we can solve for it. So if x equals -15 plus or minus the square root of 15 squared minus 4 times 1 times -54 all over 2 times 1. Of -15 plus or minus the square root of 225 plus 216 all over 2. And that would be 441 and then 2. The square root of 441 is a perfect square. It's 21. And so you have -15 plus 21 over 2, and then -15 minus 21 over 2. This one gives you -18. This one gives you 3. And then if you were to graph this on Desmos, you would have a graph that looks something like this. So the solution is 3 meters. So that was the end of this video. Be sure to keep practicing these skills and concepts before your next test.